Hello everyone, welcome back to another week with our Lee County Library Science Club. I just want to remind everybody once again that all of our experiments do have a little bit of risk to them, so please make sure you have your parents' permission and you do them with some supervision. This week, we are going to become superheroes. That's right, we are going to control the weather!
I summon the full power of the storm!
Okay, you got me. I'm not really a superhero. But we are going to make it rain right here in my kitchen. So we're talking about what's known as the water cycle. And the water cycle is the natural movement of water through its different phases to kind of recycle itself all over the planet. So this is talking about rain and oceans and how the water can move back and forth between them. In fact, most rain that happens all over the world comes from the oceans or the really big lakes like the Great Lakes. So what we're going to learn today is how the water from way out in the ocean gets all the way here to Sanford, North Carolina to fall on us as rain. So the first step in the water cycle is called evaporation. Evaporation is the process by which liquid water turns into gas, also known as water vapor. Now you may remember from last week that water is made up of molecules that contain one oxygen atom and two hydrogen atoms. But one molecule of water is really tiny. So even just a little thing of water like this is made up of millions and millions and millions of those molecules. And those molecules are all bonded together. When they're in a liquid, they're kind of loose bonds. And that's why it can just flow and slosh back and forth. What is happening in evaporation is the bonds between the water molecules are actually breaking apart so that each molecule is free to fly away and turn into water vapor. Now, breaking those bonds takes some energy, which is normally provided by the sun's heat. Now, some of you may be telling me right now, evaporation means you're boiling water. And that is true, that when you boil water, you're heating it up to a point where it's actually forcing those bonds to break no matter what else is going on around. No matter the air pressure or the saturation, you put enough heat into it that those bonds have to break and they come apart as the steam, the water vapor. This steam we see here is one of the easiest ways for us to recognize what water vapor actually is. But evaporation can happen at lower temperatures too. It just happens way slower. So what's happening is we have the sun shining down on our ocean, and right there on the surface it gets hot enough to start breaking the bonds. And actually the surface area is important to evaporation because the amount of surface that is getting the sun's heat affects how quickly the evaporation happens. Like if I took this jar, filled it up with water, and just put it outside in the sun, it would take a long time to evaporate. In fact, it probably wouldn't evaporate fast enough for us to even notice. But if I took that same jar and poured it out on the sidewalk or something, it would evaporate, as long as it's sunny, it would evaporate within just an hour or two. Okay? And that is because there's a lot more surface for the sun to heat up. Which is why things like oceans and lakes are where most of our water comes from up in the air. Now the next step in the water cycle is called condensation. And condensation is basically the opposite of evaporation. It's when all that water vapor that's flying around out there starts to reform itself back into liquid water. And so what's happening is, as we said, this, as it comes off of here, is warm. And warm air, due to having a lower density, warm air rises up. But as it rises, what do you think happens? Well, if you drove up to the top of a mountain right now, it would probably be a little bit colder than it is down here. And so as that air rises, it starts to cool. And what cooling means is that everything that's moving around starts to bunch up back together, the air and the water molecules. And so those water molecules are pushed back together and they start to reform the bonds back into liquid water. And that is how we get clouds. As the water vapor comes up, it gets high enough that it starts to turn back into little droplets of water, and it forms clouds. Now, one thing to recognize is that the droplets are really, really tiny, like half the width of your hair. One single strand of hair, half of that would be the size of the water droplets that we have in our cloud. But they are still actually liquid water and not water vapor. One of the really cool things about the water cycle and about this step is that that cloud, as it's being formed, as we learned last week, the liquid that's being formed up here is denser than air. And so you would think that as soon as it starts to turn back into water, it would just come right back down, right? But as I said, the drops are really, really tiny, and so they can be affected by air pressure. And what's happening is the warm air here, even though the water is up here, this warm air keeps rising, okay? Because warm air rises. And so it keeps pushing up on the bottom of the cloud. Even though it's cooling once it gets up here, it's still pushing up. And that keeps the water droplets up in the cloud and doesn't let them fall back down. That brings us to the next step in the water cycle, precipitation, which is when the water comes back down in rain or snow or sleet or however else water might fall back down. So what's actually happening with that precipitation is it's condensing more and more and more, and as there get to be more of those tiny droplets, they get pushed together and start to create bigger and bigger droplets. Once they reach a point where they're big enough that the warm air rising isn't strong enough to hold them up anymore, that's when they start to fall as rain. So once again, just to show, we have the sun heating the water, okay? The water here breaking bonds, turning into water vapor, rising with that warm air. When it gets up higher, it starts to cool, condenses back into liquid, and then more and more of it condenses until it forms big enough droplets that it falls back down as rain. Okay? Now there is one more part to the water cycle, but it's kind of like a side part. The fourth part doesn't necessarily have to happen, but these three definitely do. Evaporation, condensation, precipitation. But in between the precipitation and the evaporation, we sometimes also have transportation. And that's where, snow falls way up on top of the Rocky Mountains and then kind of travels, makes its way down the mountain to where it melts, turns into water, and then it runs into streams, which run into bigger streams and creeks and into rivers. And those rivers eventually run into lakes or oceans, where again, they're back in a nice big body of water where they can be heated by the sun and evaporate again. So this whole big process is known as the water cycle. And today, we are actually going to demonstrate the water cycle right here using a jar It could be any kind. I just have a regular mason jar. We're going to use a plate, but we make sure it's a ceramic or glass plate, not a paper or plastic plate. That will make a difference. And then we just need some water that's been heated. Now, you don't want to actually boil this water, otherwise it's going to screw things up a little bit. It just needs to be warm enough that it's warmer than the air around us. And now the last thing you'll need is some ice cubes. So make sure you plan ahead for this experiment and get some ice cubes ready. So the first step to this experiment, as we said, was to heat your water up. Not boil it, but just get it nice and warm. Then you're going to pour that warm water into your jar. Now you should feel that, okay, I can feel through the jar that the water is warm. We're going to put our plate on top to make sure we're trapping any water vapor inside the jar. Now we want to let it sit for just a couple minutes. Okay, now that we've balanced out and the jar isn't cloudy or anything, we've just got our warm water in the base here. We're going to take our ice cubes and put them right up on top of the jar. And what this is going to do, it's going to act like our atmosphere. Alright, so as we talked about, the water down here is evaporating and turning into water vapor. So what we have in the empty part here is water vapor. And as it rises, just like in the atmosphere, it gets colder the higher it gets. So now that we have this cooling area, you can start to see, we'll give it a couple minutes, and we'll start to see a change in this jar. Now once the jar up here has had a chance to start cooling, we have water condensing right along the top of the jar, and then it starts to run down in droplets just like rain does. If we get in close here, we can really see the water running down in droplets as it condenses up at the top of the jar. Pretty cool, huh? Now I know, we weren't quite storming in here, but I do hope you could see really how that water cycle is happening. Okay? It's a really cool process that keeps us all alive on this planet. Remember, it's evaporation, condensation, and precipitation. All the different ways that water moves around our planet. Thanks again for joining us. We hope to see you next time. Bye!